I know Anatol's going to be here. It's like he's a trainer, like a really,
Well,
really big
that's okay. We'll get to it. Okay, so as part of our effort to complete our assignment, please note, unlike what we have done in the past couple of days, I'm just going to do the entire screen. Hi, hello, hello, hello. Unlike what I'm doing in the past couple of days where I sort of walk through a lot of the assignment with you, you will be fully responsible for every single part, analyzing this as best as you can, using your own words and your own judgment. So here's your own critical thinking and your own arguments. Right? Quartiles. I talked about quartiles yesterday. So by quartiles, the root word being quarter, right? There's a lot that we can discuss when we deal with data by dividing the data into quarters. I'm not saying exactly, so if it's like 0 to 100, I'm not saying this has to be 50 and that has to be 25 and that has to be 75 as a number. As a percent, yes. Let me try to explain. Some people, the data that we deal with may not be from 0 to 100. Like what if that data, like yesterday, was, let's say, 28, 29, 29, and then 50, 55, 69, 71, 75, and then 100, 100, 100, 100. Something like that. If I were to divide this into quarters, I am not going to group all of this over 25%. I am not going to group this over 50%. That's not what I mean. What I mean by this is I see 12 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the first quarter. This would be the second quarter. It fits in here. This would fit in here, and that would fit in here. This is what I mean by quartiles. Okay, so please don't be confused with actual values. We're looking at what percentage of the numbers fit where. Okay? The words I want to talk about when we line up the data points as so is what is the median and what is the median of the first half and what is the median of the second half, because that is what these symbols represent. So I could talk and talk and talk and deal with all these definitions, but I think it's easier to do an example. Okay? And then we'll come back to talk about what it means to be exclusive or inclusive. Okay? For example, consider this. Example, here is a data set. Right now, it's all mumbo jumbo. It doesn't help us. Let us reorder this from smallest to largest. So go do that for me. 24. 36. 48. 52. 52. And 54. Okay. Okay. So when calculating, I guess, or analyzing the data, there's a variety of things we can say. We can say, hey, what's the smallest number? And what's the largest number? It's important. Sometimes you need to talk about the entire range, right? So the minimum in this case would be 24, and the maximum is 54. Oh, I didn't do 60. Wow, that's silly of me. And 60. So maximum is 60. What is the range? By range, I mean Take a look now. Okay. By range, I mean the data from the maximum to the minimum. In other words, how large is this span? That's right. So the difference. The range would be 60, so the maximum, minus 24, which is the minimum. The range is going to be 36. Another word, a casual word you might use is what's the spread? What is the distance between the lowest to the largest, right? To the lowest to the highest. And then we calculated this in our previous lesson. What is the median? Look at the numbers. What is the median, aka the exact middle number? So I'm going to count 1, 2, 3, 4, 5, 6, 7 numbers. If I start counting from outside in, okay, they are going to both arrive at that middle number because there's an odd number of data points. 52 is that middle number. At this point, we need to calculate Q1 if it's exclusive, and Q3 if it's exclusive, Q1 if it's inclusive, Q3 which is, or if it's inclusive. That's an interesting question. Okay. Take a look at what inclusive versus exclusive for Q1 and Q3 is supposed to be. Okay. Case in point, some of you asked me, how do I calculate Q1 for my data? And it all sort of depends on whether you took out the outlier or not. Some of you, I said, hey, pretend there's no number here and just find the middle number between the first half and the second half. Some people, I said, you have to include the two numbers in between. Take a look at this. If you have an even number, what happens to, let's start with odd. If you have an odd number set, that middle number is your median, right? How many numbers are in the first half before that median? How many numbers are in the second half before that median or after that median? You would have to pretend that those two sets are separate and look for the median once again. Let me try to explain using our demonstration. This is our median, right? It has been used up. Don't use that to calculate the median of your first half. So if this is the first half of my data, and this is the second half of my data, what is the median for these numbers? And what's the median for those numbers? 36 and 54. I hope you can see that visually. If not, please ask a question so that we can go further into this definition. Does everyone agree that this is the middle number of the first half of my data? Yeah, that is your Q1. So you have to figure out, am I talking about exclusive here or am I talking about inclusive here? The idea is we have excluded it. We have removed that middle number. This is excluding, exclusive. 36 and 54. And the interquartile range, in other words, the range between Q3 to Q1, that's interquartile range. We do the exact same thing. What is 54 minus 36? 18. Okay, so by definition, this is exclusive. Exclusive, let's just call it exclusive method. Okay, number of data elements is odd, the median Q2 must be, I'm going to say, excluded when calculating Q1, Q3. Is there a way I can put all this into 2 lines? Is that too small? Can you see that? Okay, so this is exclusive because I have an odd number of data. After I find Q2, get that out of the way and calculate Q1 and Q3 with what's remaining. So some of you, if you had an outlier, this is what you did. I hope you can go back to confirm whether you did it correctly. Okay? Go back to your page here. Go back to your page 5 and see if you calculated this correctly if you had an odd number of data points. Some of you, like Camilla, had an even number of data points. What were you supposed to do? Yes? Always in the front table. Sorry, go get it. Okay? So let's be like Camilla and say, did I do this one correctly? Go down, go down, go down. Oh, wait. Oh, man, I don't have an example here. 1, 2, 3, 4, 5, 6, 7. Is there another one afterwards? No, there isn't, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Here's an example in a word situation where I have an even number of data sets. So let's do this together. Question? Yes. No? Just staring at me like I'm crazy? Perfect. Let's read. We know Earth's climate is changing rapidly as a result of human activity. I am going to say that this is still not 100% clear of just how impactful human activity is. We know that we would have an effect. I don't know how impactful it is, if it's changing rapidly as a result of human activity. Information from a wide variety of sources have contributed to our understanding of climate change. For over 50 years, scientists have used satellites and other advanced technologies to collect many types of data. Ice cores drawn from Greenland and Antarctica show that Earth's climate grows warmer when greenhouse gas levels increase. And once again, cause and effect. I'm not saying climate change is not happening, but sometimes I feel that it has been oversimplified. But again, let's move on. Ancient evidence is also found in tree rings, ocean sediments, coral reefs, and layers of sedimentary rock. That's true. The table to the right shows the highest carbon dioxide emission in G20 countries. Let's say, simply put, they are the major economy countries that have growth and are also considered a large contributor to quote unquote greenhouse gases and whatever. They're the powerhouses that have, at least in the past, tried to commit to making a change in the environment. Okay? Please order this data from least to greatest. It might be a little tough, so try to do it on your own. But if not, follow me. I think the smallest number is 467. 480. Oh, it is already ordered, but largest to smallest, huh? So I will reverse the order then. 481, 487, 582, 608, 635, 674, 1082. Welcome, Anatole. I'm glad you made it. 2693, 4853, and 12,667. I'm going to ask you, in your own ability, using your own abilities, solve to number 4. Please solve number 4, and I am going to quickly pause the video so I don't record everyone's names and do an attendance. Okay. Just give you a couple of minutes. It shouldn't take too long. All right, let's do it. Max. 12,667. Min. 467. What is the range? If you forgot what the range is, take a look at the previous page. It is the maximum subtracted by the minimum. Quickly do some mental math. 12,200. In units, that would be megatons. What is the median? Well, I have an even number, so let's count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The median then, by definition from last class, is the average of these two. Yes. Did you have it? Did you find it? Oh, Liam, you made it. When did you get here? I didn't even notice you sneak in. All right, let me fix the attendance in just a second. Okay, so the median in this case, I'm going to call it Q2, is going to be the sum of these two numbers.
Oh, the sum divided by 2. It's like finding the.
I want to find the middle number of this data. So the median. So let me clarify. I'm going to say it once. The median of this entire data falls in between the 6th number we have, the 6th element, and the 7th element that we have, right? So if we want to find the middle number that's between these two, I have to find the average of the 6th and the 7th, which is 709 divided by 2, no, 1,309, 650, 4.5, thank you. Megatons. Okay, now everyone, this is important. I'm going to put a little thing here and say this is going to be inclusive. Why? There is an even number of elements. There is no middle data to exclude. The first half includes the 6th number. The second half includes the 7th number. That might not make sense from just reading, so let me demonstrate it for you. Okay? Take a look. Erasing this part. We have established that the median is 654.5. So this is the median, and we remove that number because it's used up. How many numbers are in the first half? 6. How many numbers are in the second half? 6. So 1, 2, 3, 4, 5, 6. This is going to be the numbers that you use to calculate your Q1. And this is the set of numbers that you use to calculate your Q2. How many numbers are in the front again? 6. What's the middle number? That's right, you do it again. It's not so hard, you're doing an average. Don't drop your head, come on. And the second half, how many numbers? 6. What's the middle number? The one in between these two. So again, what is the first quartile? The first quartile number is going to be the average between 487 and 582, which is, someone do that for me, and Q3, that is the number between 1909, the average, and 2693. So someone do that for me, please.
First one is 534.
534.5. And the second number, somebody? $2,301. Wow, right on the dot. Okay. And then, just like we did the range, what is the interquartile range? And that is the range of the first and the third quartile. That would be 2301 minus 534.5, which is 5.6, right? Yeah. 0, so 6, that's a 9, that's a 6, that's a 2, 9, 1. No, doesn't look right at all. 5. Okay, that's a 0. That's a 6. That's a 9. 9 minus is 6. Okay, that's a 2. 9 is correct. And then it's 2, right? So 22, 17? Wait, what am I doing? Okay, I'm doing something wrong. Someone.
1,766.5.
Okay, so I added a 9 from somewhere. Where did I do the math? Oh, that's a 22 minus 5. That's stupid of me. Okay, I'm so done. Okay. So, everyone, that's just a practice, okay? That's just an example of inclusive. Here's an example of exclusive. Okay, you can try this. I'm gonna fill this out myself and upload it onto our Brightspace. But moving to our data here, our assignment, you should be able to complete the quartiles and talk about the range. You should be able to talk about the interquartile. You do not know anything about this high or lower outliers using a IQR 1.5 rule. So don't worry about that. And then from here, you don't know what this box and whisker plot is going to look like because we have to wait until Thursday. Please stay tuned because that box and whisker thing, you will need your quartile stuff. Okay, so that was another fairly short lesson. If you can try to perfectly complete all of your, I guess, assignment so that you have less and less work tomorrow and Friday. Oh, shoot. Please notice how question 15 talks about high or lower outliers, okay? I know earlier I told you that when you are doing your graph and your data, that you are allowed to take out your outliers so that you have a better line and stuff like that. I will give you specific instructions on how to answer this question, okay? Stick to what I've told you before about keeping your outliers and identifying how you know it's an outlier or not with your correlation. Yeah, I'll tell you more information about tomorrow. So tomorrow, once we complete our lesson, you should be able to finish all of this assignment. If you finish Thursday, you essentially have a free day Friday. Okay? So in anticipation for a free work period on Friday, please try to complete as much of this up to this page and answer number 13, answer number 14, and then you can hand your assignment back. Okay? Whatever time you have in class, I would like you to work on some independent practice by using your exclusive or inclusive methods in questions 1 all the way to 4. Question?
Like what data do you put in this graph?
I haven't shown you how to use draw a box and whisker yet, and that will be on tomorrow. Okay? Any other questions?